Caroline studied that at certain places there are iron particles present in sand and soil. These particles can easily be separated with the help of a magnet. So, what she did is, she collected sample of soil and sand in two bowls. First, she rubbed the magnet in the soil. When she took the magnet out of the soil and tapped it gently, she observed that some iron fillings clinged on the magnet. She cleaned the magnet and now rubbed it in the sand. She took out the magnet and tapped it gently. This time also, she observed that the iron fillings cling to the magnet but a little more in number. So, she agreed with what she studied, that both the sand and the soil have iron particles present in it, but in different amount. For one thing, she was surprised that why most of the iron fillings clinged only near the two ends of the magnet. Does this happen with any kind of magnet? To know the answer, let's perform an interesting activity. For this, we need 4 magnets of different shapes, 4 bowls, some magnetic materials like iron fillings, iron paper clips, iron pins, and some iron nails. Put 1 magnet in each bowl with few magnetic materials of each kind. Now, pick the magnets out of the bowls one by one. What do you observe? Most of the iron fillings, paper clips, iron pins, and the iron nails cling near the ends of the magnets. But some of the materials also cling on the part away from the ends of the magnet. Now, shuffle the magnets, that is, interchange the magnets randomly in the bowls. Pick the magnets one by one from each of the bowl. What do you observe this time? The results are same, that is, all the materials majorly cling near the ends of the magnets and few at the rest part of the magnets. The regions where most of the magnetic materials cling are called the poles of the magnet. Can you count the number of poles in every magnet? Right. Every magnet has 2 poles, a north pole N and a south pole S. But what if a magnet breaks? Does it have single pole now? Let's check it out. Bring one of the broken pieces near the iron fillings. The iron fillings are still clinging even to the broken piece of the magnet. It means the magnet still has 2 poles. But is it still the south pole or it has become the north pole of the magnet? To check, bring this broken end near the south pole of another broken piece of the same magnet. Oh, they repel, which means it is the south pole. Now bring the 2 broken ends closer. This time they attract, which means it is the north pole. So, what we can conclude now? Correct. It is concluded that if a magnet is divided or broken into a number of pieces, even then, each broken piece is a magnet with 2 poles. So, 2 poles of a magnet can never be separated from each other. Finally, a magnet, irrespective of its shape, has maximum magnetic strength near its end.